In a prior lecture, we were looking very closely at how to do file uploads to an Amazon Web Services S3 bucket. And we were going through the notion of ARN, or Amazon Resource Names. We were going through the ideas of using Facebook as an authentication tool set. We were also talking about how to configure Amazon so that you could get a bit of JavaScript on an HTML page, upload it to a bucket, and then that page in itself would be able to touch the cloud. In this case, upload files to a web server, otherwise known as S3. S3 is really advertised as a file storage device that has almost infinite scalability, but because S3 operates over HTTPS, it really is just a web server. So when we are able to host websites over AWS, you're really just creating a static web server in all intents and purposes. In the past, before tech like this was available, and still very mainstream practice is to boot a Linux instance within your server farm and install into that Linux a Java or PHP or Python service that can receive HTTP and HTTPS traffic. We call that a web application service, something like a Tomcat, or many different types of services. What we're really doing right now is we're cutting out that middleman. So instead of having an application server that's running Linux for $50 a month or whatever that is, we're actually just putting up a HTML page. We're putting some JavaScript into that page, and then we're calling those cloud resources directly from the HTML, the same way we would say with a Java server page or with some embedded PHP. The difference being that there is no server on the back end. We call it serverless because we're not calling for the database through a Linux instance. We're calling the database directly from the JavaScript. Now, this introduces two advantages. One, it's more secure because we're actually asking for the Amazon Security Service to manage the issuing of a unique token to that JavaScript client. So once you receive that token, you can kind of wander around the AWS cloud according to privileges that the developer had set for you. Security goes up. Hackability goes down because you have less points of contact for folks to hack your website. For example, there are not flaws related to the Java web servlet. There are not flaws related to the Linux instance. There are not flaws related to things that are inside of your website itself. It's really just plain vanilla HTML. So things like a SQL injection are not likely to happen. And you have really Amazon, who are the same people who offer the IT services to the DoD. Even the CIA runs a version of Amazon Web Services. You really have very, very elite grade security working for you. So for the lone developer or for a small company, the serverless JavaScript really is the way to go. The future belongs to that technology. So I wanted to do more of that today, but instead of uploading files, which is really key for any kind of web-based resource, I'm going to talk about a way that we can talk to Dynamo database. Dynamo database is, of course, Amazon's flagship premier database that's extremely fault tolerant. It's very scalable. It's very hard to exhaust it as a resource. It's very cheap in that regard, and you kind of ask for the number of read-write units that you wish to have on a monthly basis. Amazon reserves that for you, and frankly, hopefully you don't exceed that limit, but they provide and reserve those instances for you at a very cheap basis, and they're there when you need them, and it will walk up and use those resources to whatever limit, and you have scalability. So you kind of have to know what your traffic is to begin with Dynamo, and as you order up more instances, you kind of have to stay on top of it. I've used DynamoDB before with a mobile app, and it works really well, but then when your traffic goes up, it actually shuts down. So you kind of have to order up more resources before you get to an exhaustion threshold. But absent that, Dynamo is a very mainstream technology. If you're using Netflix or Airbnb, you're touching DynamoDB resources, etc. So I wanted to go through what it takes to do database when it comes to talking to a website. So I have this sample that's right now up at my GitHub, and you can go on over Stefan Bunn 311, and that's the course code that I teach at Cal State, Interactive Web Development, and it's in the late stage Dynamo code example called dynamo2.html. So before you download the code though, let me just go through what's happening in the code. Then of course I'm going to give you the code and then you can begin to try it. Then I'm going to take a second video to talk about how I configure the cloud to get traffic from this web page. So let's jump in and let's define what's happening here. Okay, so we've got an HTML5 page, and within its head we are linking to the Facebook SDK for JavaScript, which is important, and then the Amazon SDK for JavaScript. And whenever this page loads, it's going to download these SDKs and cache them for you because of their URL status there. And so I'll let you put in a title, then the body opens up, and what we're going to have is we're going to have a login button that's going to trigger the login, and then once that's finished, we're going to insert a little bit of data into a table there. It's very simple. So the first thing that goes on is we actually want to trigger the Facebook login using the Facebook asynchronous initialization function, where we pass it an app ID. And that's an app ID what we configured inside of the Facebook developer console. And so we're going to initialize that, and then we're going to grab the login button. We say, okay, when we click that login button, go ahead and let's do this next inline function. So there's a couple of variables that we've set up, and a couple of them we've initialized, a couple of them we haven't. The Facebook user ID is something that we'll grab once we successfully authenticate to Facebook. Then we have the DynamoDB instance, which is not yet, it's empty right now, though we're ready to stuff it full of stuff. Then we have an app ID that points to Facebook, and then we have the role Amazon resource name. And what this is it says, hi, this is an Amazon resource name inside of AWS. And we say, go ahead and check against the identity and access management account for the role called Dynamo intro role. And we're going to go there. And so I'm going to reference this line again in a few minutes when we get back to the Amazon cloud. So when we go ahead and we click on the login button, and this is the login button right there. When we click that, we're going to ask for an authentication response. And when we get an authentication response, we're going to supply these credentials. We're going to say, go ahead, talk to this role ARN. And then when you do talk to Amazon's identity and access management, pass it the Facebook token. So Amazon is sort of saying, okay, we'll accept any user who's authenticated through Facebook. Facebook will supply you what's called an OAuth token. Amazon will accept that token, and we will configure IAM so that it will accept that token and let you wander around. Really, this idea comes from the early MIT Kerberos project, where Kerberos said, look, your server farm is like a big carnival, and once you talk to Kerberos and you get your username and password correct, you get a token, and then every time you ask for access of anything inside of the carnival, anytime you want something inside of our cloud, you present the token, and based upon your token, you receive some elevated privilege. You get to get something if you have a token. So it's very fundamental. The Facebook presents an OAuth token, which is a kind of token that many different clouds accept. Certainly Amazon accepts the OAuth token. And so, without spending too much time on OAuth, let's just say that it's good to go once Amazon sees it. And what's interesting is they accept that as a web identity credential. And what this means is that Facebook proves that you're who you say you are, and we present what's called a web identity framework credential. And once we're in there, we get to warm up an instance of Amazon Dynamo, and we get to grab the Amazon Dynamo that belongs to you. And of course, we're going to be inside whatever region you're inside, US West 2 or US West 1 if you're Silicon Valley, or US East 1 if you're among their generic Virginia services, their core East Coast services. And then what we're going to do is we're going to use something that's called the document client. And the document client facilitates putting data into DynamoDB and then getting data back out of it. So we specify the DynamoDB that we have right here. And then we indicate that you have a little success, that you're logged in. Now, the table name, and Dynamo is built out of tables, just like a MySQL. They refer to, the major block of data is a table. And we call the table website test. And inside of that table, you have a primary key called item ID. And you're going to create this unique item. And then for that item, you're going to have an attribute called F2. And you're going to fill up that attribute. And you're going to put those parameters, so these are the parameters for the item, and params that's specified here. And so we're going to put all those parameters into that document client, into this DynamoDB. And if you have an error, we'll go ahead and print it to the console on the bottom, just in case you get an error. Otherwise, we'll say, sorry, we couldn't quite log you in. And then we'll handle all of Facebook's authentication earlier with a little bit of copy-pasted code from Facebook. So now that you've got that, what I want to do is I'm going to pass you to the next video. We're going to go into our cloud. We're going to talk about how to configure that cloud.